All right, more examples. So I'm going to have this electron. He's moving in the field. I've drawn him going around in a circle so that he's always perpendicular to the magnetic field. That's actually what happens. That happens because if you're going in this plane perpendicular to the field, which is what we want for our problem here, the force is always going to point inwards towards the center of a circle. So the force is always going to point in the direction perpendicular to your charged particle in the field. And because that force is perpendicular, it never speeds the particle up and always turns it. So because it's always turning and never speeding up, it's going to end up going in a circle. And that's something we saw in Physics 1. So I think I've said this is a 1/2 Tesla field. And this is an electron perpendicular to it. And I'm going to figure out what that force is. What is that force? How would I do this? So the force here is going to be QVB sine theta I don't know what I started thinking about. I do know what I started thinking about, but I don't know why I started thinking about it. And we're going to say that it's going 1/3 the speed of light. The speed of light is 3 times 10 to the 8th meters per second, which means the V here is 1 times 10 to the 8th meters per second. B is 1/2 Tesla, and sine theta is 1. So this is theta. It's the angle between the velocity and the field, so that's going to be 90 degrees. The sine of 90 degrees is just 1. So then we have to multiply all this stuff out. So this 1.602 times 10 to the 8th, don't need to do anything with that, don't need to do anything with the 1. We have to basically divide 1.602. Let's just do 0.8. 0, 1. Then we have to do the exponents, 10 to the minus 19 coulombs, 10 to the 8. 8 minus 19 is 11. Minus 11, so we have 0.801 times 10 to the minus 11 coulomb meters Tesla over seconds, I think. Yeah, so that ends up being 0.1 or 8.01, excuse me, just move it 1 point over here, times 10 to the 12th newtons, which is 8.01 piconewtons. So not a lot of force on there. It doesn't need to have a lot of force because the mass on this thing is 10 to the minus 31 kilograms. And then what about if it moves parallel to the field? So what if it's moving this way? Well, in that case, the force is equal to 0, right? Because instead of sine theta, or instead of sine 90, you have sine 0 degrees. That's equal to 0. So this whole thing goes out. So that's basically the first example. We're using this sort of Lorentz force, QVB sine theta. And we're doing it in two situations. One where the velocity and the magnetic field are perpendicular. And in that case, sine 90 degrees is 1. This other one, sine theta is equal to 0, where the velocity is parallel to the field, and that gives you a 0 force, no matter how fast it's going and no matter how strong the field is. All right, so next we'll go on to, I think this is actually a fairly complicated one, I just don't remember what it is. but we'll go on to that one. Okay, bye now.